sklearn, utils, sparsefinks, incremean variance axis. Description. The incremean variance axis function is used to incrementally calculate the mean and variance of a sparse matrix along a specified axis. It efficiently updates the mean and variance as new data is added. This is particularly useful when dealing with large datasets that cannot fit entirely in memory, allowing for efficient processing in batches. Inputs. X. A sparse matrix representing the data. This matrix should be in a format supported by scikit-learn, such as SCPI, sparse, CSR matrix. Axis, an integer specifying the axis along which to calculate the mean and variance. 0 represents the rows, and 1 represents the columns. Last n, an optional integer specifying the number of previous data points to consider when calculating the mean and variance. This is useful for handling scenarios where the data has time-dependent characteristics and you want to focus on recent observations. Means, an optional array representing the current mean of the data along the specified axis. If none, the mean is initialized with zeros. Variance is an optional array representing the current variance of the data along the specified axis. If none, the variance is initialized with zeros. Sample weights, an optional array representing the weights assigned to each sample in the data. This allows for weighted calculations of the mean and variance, which can be useful for handling imbalanced datasets or datasets with varying levels of confidence. In the samples. Outputs. Means, an array representing the updated mean of the data along the specified axis. Variance is an array representing the updated variance of the data along the specified axis. Steps. Initialize the mean and variance based on the provided input arrays or set to 0 if not provided. Iterate over the data in batches if last n is specified. Calculate the sum of the data along the specified axis. Update the mean and variance using the sum, the number of data points, and the current mean and variance values. Metrics. Accuracy. The accuracy of the calculated mean and variance can be assessed by comparing them to the true mean and variance calculated over the entire dataset. Efficiency. The efficiency of the incremental calculation can be measured by comparing the time taken to calculate the mean and variance incrementally versus calculating them directly on the entire dataset. Visualization plots. Scatter plot. A scatter plot showing the relationship between the original data and the calculated mean and variance. Histogram. A histogram showing the distribution of the data and the calculated mean and variance. Fine-tune parameters. Last n. Adjusting the value of last n allows for controlling the window size used for calculating the mean and variance. A larger value will consider more previous data points, while a smaller value will focus on recent data. Sample weights. Fine-tuning. The sample weights can be used to adjust the influence of individual data points in the calculation of the mean and variance. This can be helpful in cases where certain data points are more reliable or have higher significance than others. Uncertainty methods. Confidence intervals. Calculate confidence intervals for the mean and variance to quantify the uncertainty in the estimated values. Challenges and fixes. Challenge 1. Numerical instability when handling very large datasets or data with extreme values. Numerical instability can occur, resulting in inaccurate mean and variance calculations. Sample use case that resulted in challenge 1: working with datasets with very large values or datasets with a wide range of values. Fixes to challenge 1: use numerical stability techniques such as using a stable mean and variance calculation algorithm, or scaling the data to a smaller range. Challenge 2: memory constraints when dealing with very large datasets. Loading the entire dataset into memory may not be feasible. Sample use case that resulted in challenge 2: datasets that are too large to fit in memory, requiring processing in batches. Fixes to challenge 2: use the incremental calculation feature of the function, processing the data in batches to avoid memory overload.